So basically, in my mind, as defenders, we really have the mission to protect, detect, and respond to different events that we're finding and looking at. And in order to detect events, the best way to measure how well we're doing by detecting things is to measure how quickly and how well we're decreasing the attacker's dwell time within our environment. That dwell time is, and in order to detect those attackers within our environment, we're really relying upon threat intelligence data sources, whether those are indicators, signatures, heuristics, or models that we're using to detect that intrusion activity. Usually, whenever we look at threat intelligence data, a lot of people, the first thing that they do is they just start counting it. So if we go out and we start scraping a whole bunch of different websites and then pulling that information into it, we end up with something that looks similar to this. What we've done is scraped a whole bunch of open source blogs, and we called that the OSINT data. So different security providers, web pages being Kaspersky, SecureList, Palo Alto, the Cisco blog, and so forth like that. Take all of that data and then pull it into our system. With that, we only have about 200, 100 different indicators every month that actually make it in that are something that will result in true positive matches. Also taking all of the indicators from the abuse.ch lists, the FIDO tracker, SSL tracker, Zeus tracker, and so forth, taking all of that information and ingesting it and applying it. Again, we only have about 200, 300 indicators every month. The malware traffic analysis blog that's run by Brad, taking all of that data in and then pulling those PCAPs, parsing those, pulling the indicators from those and applying them to systems. Again, only about 100 indicators a month. But that's a really simplistic way to look at the threat intelligence data that we're bringing in. Another thing that a lot of places do is they just look at the correlation between the false positive and true positives. And Alex, he's not in the room anymore, but he spoke about using his, I think it's the tick test of how many true positive versus false positive indicators you are looking at. Does anybody know what's missing from this? In this graph? Anyone? True negatives. So in essence, kind of your non-actionable alerts, are we speaking the same thing in that point? Or you're thinking of something that you alerted on and it should have been not malicious, but it was... Okay, cool. Well, so non-actionable alerts, whenever you take in a large amount of threat intelligence data and start applying it to SIMs and logs and firewalls and so forth, what you find out is like 99% of it is non-actionable. There's nothing to go off of that threat intelligence and find out what that really meant. You're just matching upon stuff that people have said, this is bad, here's some badness. In my opinion, that's way worse than having a true positive or a false positive. A true positive, you know it's bad. You can run it to ground, you know it's Angler, you know it's an exploit kit, you know it's going to lead to some sort of credential theft malware maybe. A false positive, you know, that was Google. It wasn't a big deal. But then all of these non-actionable alerts, you're sitting there and you're like, man, we saw all of this traffic to these different places and we've no idea what it really meant. That keeps me up at night way more than a true positive or a false positive. We spent 6 weeks trying to bring the graph down to make it so that all of the alerts that we had were either a true positive or a false positive. And that required a lot of automated systems to parse out and pull away a lot of the data, and then a lot of my analyst team working on all of the indicators that they were seeing and trying to tie that back to specific threats. You end up seeing a lot of the same threats all the time, whether it's RIG this week, the H1N1 people, or Janitor, or what have you. And after you get up on a little bit of that, it does help bring those two graphs to that meeting point. But as you can see, shortly thereafter, when the team was all about to quit after I was pushing them a little too hard, the graphs diverged pretty quickly. So one of the best ways to deal with indicators and to try to get to that point where you have things meet and you have context around all of those indicators that you're bringing into them is to produce the threat intelligence yourself. So in this graph, there are two different graphs here. One of those is based on our malware IOC feeds. And in essence, these are malware config dumpers. And a malware config dumper, if you're not familiar with it, we take pieces of malware, we figure out what the binary structure looks like, walk that binary structure, pull out the specific pieces that we're interested in, and then we apply that into the backend database of indicators. Using that, you're able to know this specific indicator came from this specific threat. And we have a handful of those right here. The backdoor feed also uses a sandbox, so if it fails at config dumping, it throws it into the sandbox and you just get the runtime information. And then the other ones are based on pure config dumping, whether that's from the binary file or from your memory allocation and carving the memory allocation and pulling that out for the packed malware. Those feeds, when you talk to malware analysts and a lot of threat researchers, everybody really loves those because of the intellectual challenge behind them. And that intellectual challenge, it's like there's something cool about taking that piece of malware and figuring out how it works and what that looks like in there. So people get really involved in it. And if you also look at the two graphs, the config dumper feeds, they're in the thousands and high hundreds, while these other sets of feeds over on the right, those are based on indicator expansion methodologies. If you were in here when Alex was talking a little bit ago, he was talking about indicator expansion as well. So this is basically the very simplistic sense is, I know bad guys use this domain. It ties back through an A record to this IP address, which then ties back to these other domains. That methodology we found to be very false positive prone, but if you rely upon registrant email addresses and then name servers, that ends up producing much more high fidelity and high quality, less false positive prone data. Specifically around a lot of the bulletproof hosters, and I don't think Dan Hubbard's in the room. Oh, Dan is in the room. A lot of the stuff that they were doing with, and I'm forgetting names right now, but people at OpenDNS were doing, they created a methodology in order to find bulletproof hosters based upon leaf nodes in AS networks. And looking for those and then finding the registrant information that's related to that information, and then applying that to your models to pull out new indicators that are being registered and created by these malicious actors has proven to be very useful for our data. But if you look at it, we don't have a whole lot of indicators coming from that. And it actually became very manual to review all of that and take a look at all of that registrant information. But it's not as intellectually challenging and stimulating and neat as the config dumping of some sorts. So a lot of people kind of discount those things. So if we kind of take a step back again and think about it, if we have threat intelligence, and threat intelligence can really support three different functions, operations, strategy, or detection, the operational world, your threat intelligence data is really helping you out with what do I do when I detect threat X, whether that's an actor, a piece of malware, or exploit kit, or what have you. Strategy is more along the lines of what threats do I have and what should I really be doing in a much larger and holistic sense to deal with these threats. Should I be applying two-factor authentication to everything because I'm dealing with a lot of compromised credentials? Things of that nature. But then the last part, and what we've been talking about mostly, is the detection area. How do I detect threat X? And if we remember, the point of my talk here is how do we reduce dwell time? If we look at Mandiant's M-Trends report, the median dwell time that for their clients is 146 days. The median dwell time whenever they receive an external notification, whether that's from a third-party security provider, a law enforcement organization, or counterintelligence organization, is 320 days. Whenever they discover it internally themselves, you're only at 56 days. The actors, they've had 56 days to operate within your organization. So I was thinking, like, how do I measure this when I'm looking at threat intelligence data? And if you think about the way that an actor sets up their infrastructure and starts using it, they create this C2 and they set up a C2. they register some domains, and then after they register the domains, they map it to a specific IP address where that C2 server is sitting on it, and then they start operating there. Sometime in the future, somebody gets popped and the indicator gets discovered. After that, you apply that indicator to your detection and protection technologies, and you have coverage, and that indicator is now rendered useless for the actor. So what I did is I took a whole bunch of domains that are being ingested as network indicators and took a look at what the delta between the date of the domain being registered to the date of the domain being ingested for detection and protection technologies, and then measured that delta. And I end up with a graph that looks like this. And these are bullet charts. In essence, the portions along the bottom describe the data points that I'm comparing the data feed against. We have our median time for internal discovery of 56 days for median dwell time. We have the external dwell time way over here at the far end of this chart of 320 days. And then this blue line is the overall median dwell time. I think if people are going to apply this and start to use this methodology internally, you would make this blue bar your median dwell time, what you normally are seeing. And our goal really is to be creating IOCs and detection criteria which will make this blue bar shrink. And then on each one of these charts, we have a marker, a black marker, that represents this feed's median time, the median dwell time between an IOC age, between when that IOC was created to when it was ingested. You can also do this with malware. So if you were looking at MD5 hashes or specific pieces of malware, you could look at the compile time, and assuming the PE build time is correct, you could use that, the delta between when the malware was compiled to when it was ingested, as your median IOC age. So if we take a look at this again, remember the indicator expansion-based methodologies of creating indicators took a lot of human resources, and it's not really intellectually challenging. And the config dumping methods of creating indicators seems to be really intellectually stimulating, but it was creating many, many indicators. But if we look at it from this perspective, if you're scraping OSINT from the web, all of our OSINT feeds that were in that first graph, the median dwell time there and median IOC age was about 160 days. So that's beyond the normal median dwell time, and it's way beyond the median dwell time for internally identified intrusions. The backdoors, using just the config dumpers that are parsing on disk file, that was all the way up here at 345 days. So you're really far out there. Does anybody know why that is the case? Any ideas? Well, in order to config dump a piece of malware, first the malware needs to be discovered somewhere. So somebody else had to have that initial median 56 days. So there's probably no way you're going to get up in front of 56 days at that point. And then you have to parse that malware and understand what that malware looks like. You need a Yara SIG to be doing virus total hunting to pull that data in. And then you need to config dump and process all of that malware itself. So you're always going to be pushed out farther and farther from that median dwell time. But then we have this malware indicators feed, and that one was really focused, and there's a lot of focus there on the Janitors and the Votrax and EverQuest and Andromeda and so forth, which are these really mass-produced malware that is really well known and really easy to alert on via virus total hunting and pull in. So that brings things down, and we're getting down to a more reasonable time span of about 75 days. But then the last thing, that actors registrant feed, using the indicator expansion, we can get our IOC age down to 2 days. And I can't figure out a way to get any IOC-based feed and threat intelligence data to be quicker than 2 days. And the problem with that is if you're relying upon who is registrant information, then you are beholden to the who is registrant providers to take all of that information of the domains that have been registered to them today. They take that at the end of the day, and then they package that up, and they deliver it to you the next day or maybe the following day. So you're already 48 hours out. And then you need to process it yourself, which puts you another 6 to 12 hours out. So you're looking at somewhere between 30 and 60 hours before you can actually get that information into your protection and detection systems if you rely upon the who is registrant information. Relying upon DNS information, you can do it a little quicker. You can see when the domain goes live on a IP address or what have you, or a CNAME. But you're still beholden to some other provider to package that data and give it back to you. So everything I've been speaking of thus far has been based on IOCs, which is really at the bottom part of the pyramid of pain. And our time to pyramid of pain was up to Alex's talk a little bit ago. But there are also signatures and analytics that we could be using, which are a little better to use. In my terminology, there are tactical signatures and strategic signatures. A tactical signature is something which covers an entire malware family, but it's not based, if you take a look at this snort signature, one of the things that you'll notice is there isn't a URI in there. And I don't know if this is something that is commonly done by a lot of people, but it's the way that I learned how to write snort signatures, and then really pushed on my students when I was a professor to apply this methodology as well. And it's to try to not look at those URIs, because the URIs are easy to change. But if you take a look at the header orders and weird things, like in this case, this oil rig backdoor, one of the weird things that I saw, the content type, binary char set UTF-8, that's really strange. Like content type text UTF-8, that makes sense. Binary UTF-8, I thought that was a little weird. I took a look at a whole bunch of weblogs to see if I could find that and stuff, and I wasn't really seeing that anywhere. So applying those applying those header orders, and especially in this case, we have the cookie first, then content type, then contents length, then user agent. That's an odd header order. And William Saluski, who's not here right now, but he has a whole paper about doing that in a more machine language-oriented way, which is pretty slick. And then the other tactical signature here is a carbon black query looking for path. NTOS kernel.exe should never be in any user's path. You know, it should be in C Windows System 32. But looking for that kind of nullifies that whole entire family of malware, and you're able to get ahead of the IOCs and ahead of any of those indicators registrant times. Strategic signatures are things which will look at an entire families or an entire technique that an actor has been using. So in this case, we're looking for process name NTOS kernel.exe, and the path's not C Windows System 32, rather than looking specifically in C users. Or let's just say password credential reuse. Nullifying that nullifies an entire class of attack. And you're not relying upon one piece of malware, you're relying upon the technique that's employed by multiple families of malware at that point. The way that this seems to work in real life is somebody discovers this offensive technique and they publish it either at ImmunityConf or Black Hat or DEF CON, and then they go out and they talk about it, and then a few months later, some actors start using it in their actual malware and for their actual attacks. And then after somebody says, oh, we actually got popped by that and we saw that, that's when people start to create a detection down here, and the technique's detected, and a few months later, somebody protects it. Right now, if you were to ask me, I'd probably say Will Schroeder's Kerberos thing is probably going to be the next thing that you're going to start seeing a lot of actors use. It's pretty slick. But the cool thing is, you can monitor for Windows Event ID 5136 and alert on that for those compromises. Or other strategic detections are two-factor authentication for the credential reuse. And then the other thing, and this is something that's very well known and a lot of people don't, but for some reason a lot of people don't block these, is dynamic DNS domains. When we took a look at all of our OSINT scraped domains that we were pulling in, 82% of them are dynamic DNS. The config dumpers, all the config dumpers and malware running through the sandboxes and so forth, 96% of the domains are dynamic DNS. So taking a step back, detection utility, if you focus on an IOC, you're only going to detect a specific sample or specific intrusion. If you rely upon tactical signatures, you can nullify an entire malware family. And if you focus on strategic signatures, you can nullify entire classes of attack. This is a little off topic, but I do have about 4 minutes left. This is a concept of how I track whether or not we have coverage for a threat. In essence, the bottom portion here is just the pure volume of data we're collecting based upon specific threat X, whether that's a malware family, actor, what have you. But then after taking that, after you have a few months of data or a few X time periods of data, what you can do is, calendar invites. What you can do is you can create this radar chart in the upper right there where the edge of the graph is the most amount of activity that you've ever seen for this threat ever. And then the blue lines, or the purple lines, are the mean amount of activity that you're seeing for that threat. So that's what we normally see. The purple lines are what we normally see. The blue lines are what we've seen, the amount of activity and indicators and samples and what have you that we've ingested for this threat during this time period. So if you take a look, the Extreme Web Bulletproof Hoster and PinSDB Bulletproof Hoster, we have about the same amount of indicators and activity that we've seen from them this time period as we have in other time periods. But then the Cerber activity there, it's way out there at the edge. So we did something that made us collect more intelligence around Cerber during this time period than we ever had before. The normal mean is way down here. And then the manipulators, we were collecting an amount of intelligence around them, but now we have much less. So something happened, we've lost visibility on that actor. We know we should apply some resources and effort in getting back up on that activity. Cool. So these are the major takeaways for the presentation and kind of concepts here. If you really want to reduce dwell time, measuring IOC age is a good way to figure out how well your data sources are helping you in getting ahead of dwell time. Better than that are tactical signatures, and the best are to apply strategic signatures. Those are the only ways that you're going to get ahead of malicious actors instead of reacting to their activities. To ensure coverage, establish a baseline of the threat and then measure your percent capture during this time period against the baseline. And if you really want to know if your detections are useful, instead of just measuring against true positive and false positive, also measure against the reduction of non-actionable alerts that you have. Are there any questions? Yes?
So I agree with everything that you just said.
Yeah.
So the model is very data-driven. So you need
Yes.
constant inputs in order to continue to refine your signature and detection set.
Correct.
Your data source that either means you're still reacting to stuff that you're seeing directly, or you're pulling from somewhere else. I know you mentioned virus total. Plus there's some open source things. But like aside from virus total, maybe checking Kaspersky's blog, what do you think about your data source to try and bring in things to reduce that dwell time where you're not going out to the 320 days of external reporting, but staying on that 56-day time?
What are good data sources?
Stuff that actually lets you produce e-signatures versus regurgitating a bunch of loads of viruses.
Yeah, so if I worked purely in a defensive organization and I was tasking people to try to create and make sure that we had good detection coverage of things, I would really be driving them to be paying attention more to penetration testers and more to the offensive classes and taking those and then figuring out and really pushing them to figure out how to detect the techniques and the strategic concepts that those people are applying and apply those to our organization first. And then the next thing that I would do there is I would really push them to, whenever the news items come out and Kaspersky releases a new report about, the equation group or threat X, to take a look at that, and instead of just, yeah, we can ingest the IOCs and pull those into our organization, but really to take a look at it and go, okay, all of these classes of technique, do we have protection against that? And tell me which ones we don't have, and then we need to go and start applying those to our systems. That's how I would run that. Does that make sense? That kind of walked around your question, but cool. Any other questions, I suppose? And yeah, there is a lot of data. We're scraping 800 different sites or something.
So when it comes to doing stuff like actual binary analysis, then you get into the problem of human resources issue.
Yes.
There's sandboxes, but I don't trust the sandboxes that much.
Exactly.
Again, look at some of the techniques that are used, what's popular, what's general.
Yeah, so the way that I run my group is that we get a client request for a piece of malware to take a look at it. We analyze it, we take a look at it, and then we go see if it's common. If there are lots of samples coming in through VirusTotal, say more than 2 a day, or multiple a day, I guess, at any point, then I'm going to try to get them to write a config dumper for it so that we never have to look at that sample again so long as the config dumper works. And then once it stops working, then we need to fix that config dumper, if that makes sense. Cool. Yeah, cool. Any other questions? Cool. So thanks. If you need to contact me, I'm just Aaron at Anomaly or Shelmire on Twitter. Thank you for your time.